Hello guys, welcome to your channel Learning Point. Today we are starting with a very simple chapter which is application of derivatives of Maths 1, which is a part of 12th Commerce new syllabus. Now before starting with this chapter, I would like to suggest you one thing, that this chapter is completely dependent on the previous chapter, differentiation. So in case if you have not studied differentiation, or if you are having any doubts or difficulties in the differentiation chapter, I would suggest that first go and revise, go and understand all the sums, all the concepts of that chapter. I am giving the links of all the videos of that chapter in the description box. First learn all the formulas, all the concepts of the differentiation chapter, and then come back for this chapter so that everything goes very smoothly for you. Because as the name says, application of derivatives, we should first know the derivatives of all the types of functions that we are having in the previous chapter. Now for all those guys who have already studied the chapter differentiation, let us proceed with this chapter. The first part of this chapter says it is based on equation of tangent and the normal. Now before directly going to this particular part, there are some basic points that you need to see over here. See, in the previous chapter I had told you that if y is equal to fx, is a function of x, we say that dy by dx is equal to f dash x is the derivative of y with respect to x. This is what we had already seen in the previous chapter. Now here we have to know one more interpretation for dy by dx, which says it is slope or gradient of a tangent to a curve at a given point x1 and y1. So suppose in case if I consider that this is a curve whose equation is y is equal to 2x square minus 3x plus 2, and suppose if I have a tangent which is suppose going on something like this. If I have a tangent and I consider this point as suppose minus 2 comma 3, and I need to know the slope of this tangent, then it is very easy. We just have to differentiate the given function of y and then substitute the given value of x and y in their respective places. Obviously when you are substituting over here, only we have to substitute the value of x because it is a function of x. So let us see what we get. Slope of tangent, first I consider y is equal to 2x square minus 3x plus 2, and I differentiate this with respect to x. So when I differentiate this with respect to x, I get over here dy by dx. This 2 is the coefficient, so that remains as it is. Derivative of x square, as you already know, it is 2x. 3 is the coefficient and derivative of x is 1. So students, I get the answer dy by dx as 4x minus 3. Now I can say that at x is equal to minus 2 and y is equal to 3. It is not necessary to write this. We just have to substitute the x value, so it's okay if you write this or not. So suppose if I consider x is equal to minus 2, I will get slope of tangent. If I represent this by m, then I can say that m is equal to 4 into minus 2 minus 3. We are using this equation over here for substitution. So I get minus 8 minus 3, which is equal to minus 11. So that becomes the slope of the tangent. Isn't that very simple, guys? So this is the way we can find out the slope of any tangent for any given curve. So that is one part of your solution. Now let us see the second thing. What is the normal? So let us discuss about the normal. A line perpendicular to tangent at a point where tangent touches the curve is a normal. So guys, we also should know how to find out the equation of the normal and the slope of the normal. So in order to understand that, first I will go to a small recap of the 11th standard, the chapter of coordinate geometry, the chapter of equation of line, and then once again I'll come back to the normal. So let us understand how to find out the slope of a line which is a perpendicular to the given line. So see guys, in 11th standard you have studied if lines L1 and L2 have slopes M1 and M2. There are two cases, L1 parallel to L2 and case B, L1 perpendicular to L2. In our case guys, this is important over here for now, but this also should be known to us because in certain examples of our exercises we will also need the concept of parallel lines. So that's why we are discussing is this thing right now. If lines L1 and L2 are parallel, we say that slopes are equal. So what does that mean? It means that M1 is equal to M2. Whereas if the two lines are perpendicular to each other, then we say that product of slopes is equal to -1. So according to that, it means that M1 into M2 is equal to -1. So that is the way we will be able to find out the slope of the normal when the slope of the tangent is known, or if I am knowing the slope of the normal, I would be also able to find out the slope of the tangent because the lines would be perpendicular. Now we have seen over here that the line perpendicular to the tangent at a point where the tangent touches the curve is a normal. Now in our above example, we knew that slope of the tangent is equal to -11. Suppose if I assume, let this be M1 and if slope of normal is equal to m2, I can say that m1 into m2, if it is equal to minus 1, so it means that minus 11 m2 is equal to minus 1. So according to this, guys, m2 is equal to minus 1 upon minus 11. So you can easily tell that m2 is equal to 1 by 11, but which is nothing but the slope of normal. Now this is the way we will be able to find out the slopes of the perpendicular lines and the parallel lines. In case now the question comes to find out the equation of the tangent and the equation of the normal. Once again, for this, students, let us go to a small recap of the 11th standard equation of a line. Now in 11th standard you have seen different methods for finding the equations of the line, but over here the most important one is the slope point form of a line. Now what does that mean? Suppose if I consider that we have a line, let us assume L1, which passes through a point, say P x1 comma y1, and the slope of this line is known to be m. Then according to the slope point form, the equation is y minus y1 is equal to m multiplied by x minus x1. x1, y1 is any point which is lying on that particular line that is known to us, and m is the slope of that particular line. So in such a case, I can say that equation of the line using the slope point form is y minus y1 is equal to m into x minus x1. Other than this, the other equations of line that you had studied was the slope intercept formula, according to the slope intercept formula, it says that if these are our x-axis and the y-axis, and suppose if you have a line which is passing like this distance from origin to the point where the line touches the y-axis is called as y-intercept, and the slope of this line is equal to m. If this is known, we assume that the y-intercept is denoted by c. Then in such a case, equation is y is equal to mx plus c. This is the method we can use to find out the slope of the line with the help of a given equation of a line. Now what does that mean? Let us understand this with the help of an example. Suppose if I want to find slope of line having equation 3x minus 5y is equal to 2. What I will do over here is I will try to express the given equation in the form of the slope intercept form. How do we do this? It is very simple. Let us see. We say over here 3x minus 5y is equal to 2. So I say 3x minus 2 is equal to 5y, and therefore 5y can also be said as 3x minus 2, because you know that if a is equal to b, b can be also said to be equal to a. So this helps me over here by taking it like this: y is equal to 3 by 5x minus 2 by 5. What we have done is we have just cross multiplied the value 5 from left to right. And now guys, if I say compare with y is equal to mx plus c, I can see that the coefficient of x over here is the value of m. So easily I have got the value of m as 3 by 5. So this is the second method to find out the slope of the line that we have seen today. The first method that we had seen was by using the derivative, but the derivative requires the condition that it should be a tangent. If the line is a tangent to a curve, only then you can differentiate the equation of the curve, and you will be able to 100% find out the slope of the tangent. But in case when it is not told that the line is a tangent and still I want to find out the slope of that particular line, so guys, this is the best idea to find out the slope of a given line. Now the question comes, how do I find out the equation of the tangent and the equation of the normal? Let us go to our previous example. We had taken the equation of the curve as y is equal to 2x square minus 3x plus 2. Equation of curve y is equal to 2x square minus 3x plus 2. We have also calculated slope of tangent at the given point. The given point was minus 2 comma 3, and the slope of the tangent was minus 11. Let us represent m is equal to minus 11. Now see guys, the tangent is passing through the point minus 2 comma 3, so I can assume that x1 comma y1 is minus 2 comma 3. So my x1 value becomes minus 2 and y1 value becomes 3. So I can say that equation of tangent, by which method? By the slope point form or the slope point method. It is y minus y1, which is equal to m multiplied by x minus x1. So students, m over here is minus 11, x1 and y1 are minus 2 and 3. So let us substitute the values very carefully. Y minus y1, which is 3, m is negative 11, and I will get over here x minus negative 2. Therefore y minus 3 is equal to minus 11 into no. Therefore minus 11x minus 22. Sorry guys, there was some interruption over there. So take this 11x on the opposite side, this will become positive, is equal to minus 22 plus 3. So 11x plus y, this becomes minus 19. So guys, this becomes your simple calculation or the simple formula or the method to find out the equation of the tangent. Now suppose in case if I want to find equation of normal. See students, the method over here again remains the same. We will be using the same equation, but in this case I will say that the slope of the tangent, in fact the slope of the normal, that we have calculated, it is 1 upon 11, and also the normal is also passing through the same point. So I will again get x1 y1 as the same numbers, minus 2 and 3. Therefore equation of the normal is the same equation, y minus y1 is equal to m multiplied by x minus x1, but this time students, this will be of the value of m over here, and this will be your again x1 and y1. Therefore I can say that y minus 3 is equal to 1 upon 11 multiplied by x minus of minus 2, so I can write it as x plus 2. Cross multiply this 11 on the opposite side. 11y minus 33 is equal to x plus 2. Transfer this 11y over here and 2 on the opposite side. So the equation of the normal becomes x minus 11y is equal to minus 33. So students, that becomes your equation of the normal.